Okay, Assalamualaikum and greetings to everyone. So today we'll be dissecting a journal entitled LLM PBE Assessing Data Privacy in Large Language Models. So our group consists of me, Aliya, and my two other group mates, Ahmad Iman and Muhammad Danish. So the problem addressed in this paper mainly concerns the privacy of sensitive data. This is because LLMs are trained on a vast amount of text data like books, websites, and articles, which include sensitive data like personal information, copyrighted content, and maybe even company secrets. That being said, there is such a high chance for these LLMs to memorize those sensitive information and accidentally leak them when someone is chatting with it. So the objective of this paper is to introduce a toolkit that they had created called LLM PBE. The toolkit helps anyone to test how much an LLM model memorizes, what kinds of leaks are possible, and which privacy protections are working or not. So they use this toolkit to test different LLMs under attack, study how data features, model size, and model release timing affects privacy, and lastly, they use it to try out privacy defense methods to reduce risk. So to carry out their research, they tested the toolkit they created on datasets with different types of privacy-sensitive information, which are Enron emails for personally identifiable information (PII), ECHR court cases for legal text, and lastly, GitHub repos for copyrighted code.
Now let's see what they have done in their research. First of all, they have evaluated four of the same types of LLM called Pythia, and they are all trained on the same dataset that includes Enron emails. And for each of the model, they measured how well the model is at answering questions and reasoning, and how often the model leaks private information such as the Enron emails. And from this, they found out that as model size gets bigger, their reasoning accuracy rises only a little bit, but their tendency to leak emails and private information rises much faster. For example, as you can see, for the 12 billion parameter model, it leaks far more Enron emails than the 1.4 billion parameter model, even though the accuracy between the 1.4 billion parameter model and the 12 billion parameter model only differs for a little bit. Okay, so for the research methodology number two is that they also dug into what kinds of training data that leaks more easily. And to do this, they trained the model on ECHR legal documents, which contains about 11.5K court cases. And they try extracting different private informations using a fixed prompt. Now, for the findings, is that they realized that textual info, like names, leak at 20 to 30% success rate, whereas pure numbers only leak about 10 to 15%. And what does this mean? Is that words are easier to memorize and leak compared to numbers. And they also found out that private information that appears at the very beginning of the sentence leak more. As you can see, it's about 30% compared to those in the middle, which is 25%, and those at the end, which only leaks about 20%. And why is this? Because transfer models pay more attention to the first few tokens of the sentence.
First limitation is that the paper only tested on a handful of LLMs, but there are many others such as GPT-4, Gemini, or DeepSeek, and there are hundreds of other smaller ones. Second is that it only tested on a few datasets. Therefore, in datasets with more personal information, such as bank information, it could behave differently or dangerously. Future works. Firstly, study how privacy risks change as models are updated or trained. Secondly, expand the toolkit so that we can use it on new models. And finally, and most importantly, when making the model, the primary thing in mind should be to create stronger privacy defenses without hurting the model's usefulness. Thank you, Doctor.